There we go. On bell work today, we're saying let g be the function given by that. Okay, g of x is equal to that integral from -1 to 3. On which of the following intervals is g decreasing? Show me with your fingers. 1 for A, 2 for B, 3 for C, 4 for D, 5 for E. What'd you get? Not getting a whole lot of answers. We got a couple. All right, let's see. All right, so g is this. G of x is equal to this guy right here. Okay, and then it talks about where is g decreasing. Now, it's a little strange here because they told me g, but g is an integral. That's weird. Okay, if g is an integral, and I'm talking about g decreasing, what do we normally look for on a graph if g is decreasing? It's a terrible question. I don't really know how to graph integrals. Okay, but what do I know? I know how to graph g prime. I know how to graph the derivative, right? If we figure out what g prime is, I need to take the derivative of this integral. Can we take a derivative of an integral? Yeah, that's what we did all last chapter. Okay, to take the derivative of an integral, you make sure x is in the upper bound. It is. We plug it in, and then we would multiply by the derivative of whatever I plugged in. So what would I have to multiply by here? Just 1. So g prime is going to be equal to sine of x squared. That is the derivative. That is g prime. That's what I want to graph. I do not want to type in an integral into my calculator. It won't work, okay? It takes forever, and it won't do very well. It's asking for when g is decreasing, though, and it gave me g prime. What am I looking for on my graph if I want g to be decreasing, if I'm looking at a g prime graph? G prime needs to be, g prime is negative. That is what I'm looking for. I want to know when g prime is negative. Write that down before you go to your calculator. Because otherwise, when you go to your calculator, your brain's going to play tricks on you. Okay, so I go to my calculator. I hit y equals. I typed in sine of x squared. I messed with my window, making sure I'm in radians. And then I graphed it from -1 to 3. I zoomed in my y min and y max a little bit just based on the picture as well. I type it in. There's my picture. We said g is decreasing when g prime is negative. So what am I looking for on this graph if I want g prime to be negative? Negative, yeah, below the x-axis. Boom, right here. That's the place I care about. Okay, just looking at those multiple choice, we can use our brain. It's not that one. It's not that one. It's not 2.8. You can kind of see that that's 1 and that's 2. So you're thinking it's either C or D. Let's just double check. That looks like 1.772, but let's just make sure. So we're going to go second, calculate. What am I going to find if I want to know that value? The 0. Let's go to the 0. So I'd go to the left a little bit, hit enter, go to the right a little bit. Again, we're trying to see, is that 1.772? Boom, it's 1.772. So from there until there, which based on the multiple choice answers is going to be 2.507. Questions with how we set that thing up? It's a good question about talking with calculators, but also thinking about graphs and what we need. We good? All right, grab your whiteboards. Let's do some whiteboard stuff. Go. Here's all you're doing on this first one. Just show me setup. Okay, this would be a calculator question. I trust in your ability to do calculator. Make sure you can do all this on your calculator. But for number 1, show me your setup. The function v of t is given in meters per second. The position of the particle at t equals 1 is 3. Find the total distance traveled by the particle. Right on your board, hold it up. We're finding total distance traveled. So if I'm finding total distance traveled, how do I find total distance traveled? Your absolute value of what? The velocity equation. Okay? Several of you tried to write velocity and you wrote this equation, but all you wrote on your paper was e sine x. That is not velocity. It's e to the sine x times cosine x. So you forgot part of that. That would be wrong. And so if it tells you v of t, then just write v of t, because if you write down the wrong equation, it's wrong. Okay? We throw a dt at the end always. We want total distance traveled on the interval. What's my interval? 0 to 2 pi. I don't need anything else. If it's total distance traveled, do I care about where I started? No, I don't care about the start. That's it. You would write that down on your paper. That would score you a point. You would type it into your calculator and hit enter. That would score you a second point. Questions on the first one? Yeah, you got to. You have to. That's the problem. I've done this problem before on tests and people forget it. It's there. It's right next to it. Don't forget it. There's the next one. All I want you to do is talk. Just talk with your neighbor and decide what you would do here. Go. See, if I want to know when is the particle moving backwards, obviously you would type this into your calculator. Okay, I'm just going to throw it on decimals here for a second. Here's my calculator. What are you going to look for on this graph to figure out when I'm moving backwards? When are you moving backwards? When what is true? Velocity is negative. This is a graph of velocity. So when is it negative? From right there at pi over 2 to right there at 3 pi over 2. Those would be my values. All I would do is calculate. This is velocity. When am I below the x-axis? At those two spots. What would be my justification from there to there? Because velocity is negative. Done. That's scoring me my points. Next one. Write it down. Show me your setup. You don't have to actually type it in, but show me your setup. Go. Here we go. We look at this problem. They told me velocity, and they're asking about position. If they're telling me velocity and they're asking about position, this is a start plus change equals n. So write it on your paper. I didn't see that by anybody. That's going to help you be successful. Start plus change equals n. What of those things do I know? The start. I know that at t equals 1, x is 3. So that means that's the time at t equals 1, my x is going to be 3. So 3 goes there. What am I trying to find out in the end? Position at 4. So that's t equals 4. That's what I'm looking for. This is my mystery number. So to find that, I need to do change. To do change, I'm integrating. From what two x values do I care, or what two times do I care about? 1 to 4. Look at it. It's right there. It's 1 to 4. Okay, so we're integrating this thing from 1 to 4 v of t dt. That's my setup. I would type that into my calculator, 3 plus the integral from 1 to 4 v of t dt. That would get me my answer. Questions on C? Just looking at letter D. Okay, we don't even have to give you a second to think about this one. What is the acceleration of 3.5? I told you velocity. What would you do to find acceleration? Derivative. If it's a calculator question, do you actually need to find the derivative? No. All you would need to write on your paper is v prime at 3.5 or a of 3.5 equals blank. You type in your calculator, you hit math 8, you hit enter, that gets you an answer. Everybody good on that one? Let's go to the next one. This is a graph of velocity. They're asking about position. We just did one like this. Think about what you need to write down. Get me an answer. I'll help you out with area because I know it's hard to see from your seat. 2. That's 2, 1, 2. No, that's 4. Go. Just playing, that's 2. Again, the key as I look at this question, this is a graph of velocity. They ask me for position. If I'm going from velocity to position, I've got to do start plus change equals end. Okay, what do I know here? Well, I know, and again, it's moving on the x-axis, so we hate when they do that, but they do this weird thing where x and t, but that's all right. Okay, t equals 10. What is that going to be here? Is that going to be my start or my end? It's my end because it's the bigger of the two numbers. Technically, you could start with it. You don't want to. Put it at the end. Okay, t equals 10. What is the value? It's going to be 2. Find the position when t equals 2. So I want to know this guy. This is my mystery number. To do that, I need to figure out the change. A change is the integral of velocity. From when to when do I want to find the integral? 2 to 10. The start to the end. So I'm finding the area from 2 to 10. So if I do that, that's 4, 5, 6, minus 2. So it's 4. The change is 4. So something plus 4 equals 2. What plus 4 equals 2? Negative 2. Negative 2 plus 4 gets me 2. Makes sense on where I'm getting that from. It looks weird. When I would have tried this one as a student, I would have tried to work backwards. It gets kind of hard. It's much easier to write it out in that capacity. I think it's going to be helpful to your brain. Try the next one. Okay, I want to see your setup and I want to see the calculator answer. So break out your calculator. Get me an answer. They told me a rate and asked me how much gasoline I use, so I'm going to integrate. I'm starting at t equals 0. I'm going for 2 hours. So I'm integrating t square root of 9 minus t squared dt. Make sure you can type that in your calculator. 5.273 would have been my answer as I typed it in. Try the next one. Now we're finding the average rate of gas consumption from t equals 2 to t equals 6. Talk with your neighbor. You don't have to actually get a calculator answer. Just show me setup. Let's look. We're finding the average rate of gas consumption. What did they tell me initially? What is this equation right here? It's a rate. This is the rate of gas consumption. So if they are asking me to find the average of the thing I'm given, if they're asking you to find the average of the thing I'm given, I integrate. I want to do it on this time interval, so it's 2 to 6. I'm going to integrate that rate. It gets me that. Okay? If I want to find, that's going to tell me the gas consumed. That's what we did right above. That'll tell me the gas consumed. But if I want to find the average rate, then I divide it, or I multiply by 1 over upper bound minus lower. So 6 minus 2, which is obviously going to get me 1/4. Okay? That's my setup. If I'm doing units, I am finding the average of what is given. So if I'm finding the average of what I'm given, the units do not change. So if it was gallons per hour, it's going to stay gallons per hour. Because we said on the last part that right there would tell you gallons. But this 1/4 is 1 over time. So if I multiply by 1 over time, which is hours, it's back to gallons per hour like we started with. Okay, if I just integrate, that's going to tell me gallons. But since I integrated and multiplied by 1/4, now it's just gallons per hour. Makes sense on that one? Try the next one. Here we go. If we're looking at this first one, we're finding G of -1. It tells me right here that G is the integral from 2 to x. So if I'm starting at 2 and I'm going until my x value of -1, it's a 3, but what's my actual answer going to be? -3, because you're working backwards, because you're integrating from 2 to -1 of that f of t dt function. So since I got to go backwards, my answer is going to be -3. G prime at 3. So what am I looking for right here at 3? What do I want to know? The point, because this is a graph of f, the integral is g prime, and so the answer is just -1. G double prime at 6. What am I looking for right here at 6 if I want to know the second derivative? The slope. The slope of that spot is 0, so that is my answer for that one. Questions on anything there? Let's try another one. Okay? Figure out where g of x is decreasing. Justify your answer. Go. Here we go. Let's look. We are trying to figure out when g is decreasing. This is a graph of f. They told me f, but they're asking about g. So what's the first thing I need to do? Link them. F equals g prime. Write it on your graph, but also right here, just write f equals g prime. Okay? What needs to be true about g prime for you to be decreasing? G prime is negative. And then this is a graph of g prime, so I'm just looking for when it's negative. The answer is -5 to -1. You would put that in brackets technically because I'm talking about the first derivative. And then from 2 until 6. Questions there? Last one, find the minimum value of g of x. Justify your answer. Remember, g of x is the integral. I'll write it down here. G of x is the integral from 2 to x of f of t dt. Justify your answer. Minimum value. Do that. Go. This is an important one. Probably worth the most points out of any question on tomorrow's test. We are finding the minimum value of g of x. And then we are justifying our answer. We are finding a minimum value or a maximum value. How do you justify a minimum value or a maximum value? A table. Okay? We're going to make a table. It's going to have x's in it and g of x. What places can have a maximum or a minimum? Endpoints. So make sure you have -6 and 6. What else do I need? Critical points. -5, -1, and 2. I would list them all. I know some of you were just listing -1, 6, -6, and 6 because -1 is the only place you can have a minimum. I'm okay with that. I'm not sure on the test. So I'd rather just put them all. I don't want to screw that up. Okay, let's find the easiest one first. So I'm integrating from 2 to x. So from 2 to here is going to be negative 6 there. From 2 to 2 is going to be 0. From 2 to negative 1, I'm working backwards. We said that one just a second ago. That's going to be a negative 3 because I'm working backwards. As I work back this way, it's going to be a negative 3, but it's going to be plus a 2 pi. And then as I keep working back even more, it's negative 3 plus a 2 pi, but then minus a 1 because it's up above. I'm just working backwards. What is the answer to the question? Find the minimum value of g of x. What is the minimum value of g of x? Negative 6, not 6. 6 is where it happens. What is the minimum value? It's the g of x that's associated with that. Questions on that one? Worth a ton of points for tomorrow. Make sure you can handle that.